Geometry students to page 444 homework video, homework help video part 2. Sorry about the interruption there in the last video. Had to take a break there for a little bit and come back and finish the video now. Alright, number 24. Okay, let's take this step by step. Everything I want to do here, I want to do it logically and proving it, okay? So, I mean, sure, I look at this and I'm pretty sure, like 99.9% sure, it's a square. Okay, but on a test or a quiz, I'm going to ask you to prove it or just tell me how you know that. So here we go. Step 1, 2, 3, right down the line. First of all, I notice that I have a what? It's a quadrilateral. Okay, next, I notice that I have diagonals that are congruent. Okay, now, whenever diagonals are congruent, that's supposed to be a rectangle. Okay, so I know I'm heading toward having a rectangle here. Now, next, I know this length here is 1, and because there's 2 marks here and 2 marks here, I know this is a 1 also here, okay? So, I know that if I check to see if I have a Pythagorean triple here, if I take my 2 short legs, 1 squared plus 1 squared, and set that equal to my longer leg squared, 1 times 1 is 1, 1 squared is 1, 1 plus 1 is 2, square the square root of 2, you get 2. So I know that I have a right triangle over here, okay? And so, I know this is a right angle here. Alright, now think about it. All these triangles are going to be identical. I have a 1 here, a 1 here, and a 90 degrees here. So I know this is going to be square root of 2, and on it goes. So far I know I have a quadrilateral. I know I have a rectangle. Now I know all of the sides are congruent. So I'm dealing with a rectangle that has 4 congruent sides. What is that? See how I prove that? I started off by saying I know I have a quadrilateral. Then I said I know I have a rectangle because my diagonals are congruent, because there's 2 marks here and 2 marks here, and then there's 2 marks here and 2 marks here. That means this whole line here is congruent to this whole line here. Only time you have congruent diagonals, you have a rectangle. So I know I have a rectangle. So then next, I say to myself, okay, I've got 4 congruent sides. So what figure is a rectangle with 4 congruent sides? That's a square. Okay, alright, number 25. Now, let's start off very basic. I know that I have a quadrilateral, okay? 4 sides, no problem. Next, I notice that the diagonals bisect each other. In other words, this line crosses right here, so that this segment here is congruent to this segment here. And I notice that this line here crosses right here, so that this segment here is congruent to this segment here. So the 2 diagonals are bisecting each other. What did we learn? We learned 5 ways to prove that a quadrilateral is a parallelogram. If both sets of opposite sides are congruent, if both sets of opposite angles are congruent, if both sets of opposite sides are parallel, if one angle is supplementary to both of its consecutive angles, and then lastly, if the diagonals bisect each other. So these diagonals bisect each other, so I know that I have a parallelogram. Okay, now, let's see what else I know. I know that if I take this triangle here, right here, and if I try to see if I have a Pythagorean triple, I do. If I take my 2 shortest legs, 3 squared plus 4 squared equals my longest side, I will get 25 equals 25. So I know this is a right triangle because I have a Pythagorean triple. So I know there's a right angle here, okay? Right here. So there's my right angle. Now, we learned that whenever diagonals are perpendicular, we have a rhombus. Okay? We learned that, guys. That's why it's so important you know all of these things that we've learned, all these postulates and corollaries and theorems. So we know it's a quadrilateral by looking at it, a 4-sided figure. We know that's a parallelogram because the diagonals bisect each other. We know we have a right angle here because the Pythagorean triple. So we know it's a rhombus because a rhombus is a parallelogram. And anytime the diagonals are perpendicular, anytime a parallelogram has diagonals that are perpendicular, then you know it's a rhombus. So this is a rhombus. Okay, moving on to the reason we skipped 26 is we have yet to look at kites. That's one of the extended lessons that we'll have. If we have time, we'll go back and look at the end of the school year, okay? Alright, moving on to number 27, okay? We're going to prove this now. Let me get some numbers up here that we're going to use, okay? I love using numbers for angles. I'm going to call this angle 2, I'm going to call this angle 3, and I'm going to call this angle 4. Okay, I just like using numbers for angles. Now, AB is 4, so here that is right here. BC is 2, that's right here. AC is square root of 10 right here. And angle 1 is acute. Okay, excuse me, we're going to prove that angle 1 is acute. Now here's how I think we're going to go about doing this, okay? I think we're going to have to show that angle 2 is acute. And once I show that angle 2 is acute, well, angles 2 and 1 are congruent, so then 1 has to be acute, okay? Somehow I'm going to have to use that. I think one way to do that, guys, is to show that I have an acute triangle, or if I can show that I have an obtuse triangle, then I know this. Now listen to me. This is the longest side because the square root of 10 is 3 point something, I don't know. And this is 2, and this is 4. So this is my longest side. So if I have an obtuse triangle, the largest angle is always across from the longest side. So if this is an obtuse triangle, then this is my obtuse angle. And that would make these two angles acute angles. Think about it. If this is greater than 90, like 100 degrees, then these two angles here have to be acute. They have to. Okay, an obtuse triangle only has one obtuse angle. We learned that, okay? So my goal here is to either show that I have an acute triangle or an obtuse triangle, and then tie that into angle 2 being congruent to angle 1 and going from there, okay? So let's get after this. It's not going to be super easy, but we can definitely do this, okay? So here we go. Step number 1, of course, like usual, I'm going to just put a line here and put given. So I'm going to give my given, okay? Step 2. Now, I'm going to state that triangle ABC is obtuse. Okay? And the reason I can do that is I'm going to say that the square root of 10 squared plus 2 squared is less than 4 squared. Okay? So that's my reason. Remember, we learned that in the lesson today. If the sum of the squares of your two shorter sides is less than the square of the longest side, then you have an obtuse triangle. So I'm going to state that triangle ABC is obtuse. Now think about it. Come on, guys. If I just state a triangle ABC is obtuse, next I'm going to state which angle is obtuse. Well, I'm going to state that angle 3 is obtuse. Or instead, I'm going to say the same thing. I'm going to say angle 3, the measure of angle 3 is greater than 90. That means it's obtuse. Now, how do I know that? I'm going to put 2 reasons over here. Usually I don't do that, but I'm pretty laid back with your proofs as long as I can follow you and understand what you're doing. Well, first of all, I know that the measure of angle 3 is greater than 90 because definition of obtuse triangle. The definition is I have to have one angle greater than 90. Now, how do I know it's this one? Well, that's my other reason I'm going to put. It's across from the longest side. Think about it, guys. This angle right here is across from the longest side. So this has to be the biggest angle in the triangle. So it has to be the obtuse angle. Okay? So the measure of angle 3 is greater than 90, or you could say it's obtuse. Either way is fine. Now next I'm going to state this, okay? I'm going to state that angle 2 plus angle 3 plus angle 4 equals 180, okay? That's the 3 interior angles, 2, 3, and 4. And of course, the reason for that's very obvious. 3 angles of triangle equals 180. Okay, that's pretty obvious. Now look what I'm going to do for step 5 here. Watch this carefully. I'm now going to make a substitution because, guys, students, somehow I have to get 1 incorporated into this statement here because somehow I've got to prove that 1 is acute. So I'm going to state that angle 1 is congruent to angle 2. And I'm going to state that because they're vertical angles, okay? Vertical angles congruent. If I want to be really, really picky, I would make you first state that angles 1 and 2 are vertical by definition of vertical angles, and then you can say they're congruent, but I'm not really that picky. Again, as long as I can understand what you're doing, I'm good with this. So let's review. I first of all stated triangle ABC is obtuse based on this here. Then I stated 3 has to be the obtuse angle because it's across from the longest side. Then I stated my 3 angles on the inside equal 180. Now I've stated that 1 is congruent to 2. Okay, so I'm running out of space here. Let me do something real quick here that might help. I hope it'll help a little bit. Alright, let's grab this and slide all of this up here. Get us a little more room. Hopefully. Alright, now, look what I do next, guys. I stated that 1 is congruent to 2. So look back at step 4, where 2 is. I'm going to substitute 1. So now I have angle 1 plus angle 3 plus angle 4 equals 180. And of course the reason would be substitution. I substituted 1 for 2. Okay? Now, next, look guys, I'm trying to do something where I can show that 3 is obtuse and get that worked in here and lower this 180 down to a 90. And I'll show you what I'm trying here. Now look at this. I'm going to state next that angle 3 equals 180 minus angle 1 minus angle 4. And of course that reason would be substitution. Subtraction. Now look what I did, guys. Come on, watch. I brought the angle 1 over here and made it negative, and I brought the angle 4 over here and made it negative. So thus I now have 180 minus 1 minus 4. Now, students, look carefully what I can substitute here, okay? I have hold on 1 second here. Okay. I have all of this right here equals what angle? Angle 3. So why could I not pick that up and put it right here for angle 3? Well, the answer is I can. That's called substitution. So I'm going to pick this up here and put it in for this up here. So now I have 180 minus the measure of angle 1 minus the measure of angle 4. I put all that in for this is greater than 90. That's substitution. Okay, now we're definitely running out of room. I'll try to finish it up here. That's substitution. Now, bear with me, students. Please watch this, okay? For step 9, look what I'm going to put. Now watch this. I'm going to bring the 90 over here and make it negative. And I'm going to bring the 1 and the 4 over and make them positive. So now watch. If I bring the 90 over and make it a negative 90, that's going to leave me with 90. And if I bring the 1 over and the 4 over, then I have greater than angle 1 plus angle 4. Now the reason for that is going to be addition and subtraction. Now again, I'm not a big fan of putting 2 reasons on one line, but we're going to do it here. When I brought the 90 over, I subtracted it. When I brought the 1 and the 4 over, I added it. So using addition and subtraction, I get this right here. Now students, use common sense. Look at this, guys. Look. For step 10, I'm going to state that 90, now bring angle 4 over and make it negative, 90 minus the measure of angle 4 is greater than the measure of angle 1. You're finished. Look what you have stated here. You have stated angle 1 is less than 90 minus an angle. Now we know this angle here can't be 0. It's impossible for an angle of a triangle to be 0. So we know it's not 0. So I don't care what this angle is. Whatever angle, I don't care if it's 1 degree. If it's 1 degree, 90 minus 1 is 89. So there I've showed you that the measure of angle 1 is less than 90 because the measure of angle 1 is less than, if you read it from here, the measure of angle 1 is less than 90 minus an angle. So now I can state easily angle 1 is acute. This is not easy. I knew that it wasn't easy, but that's how you do it. Guys, it would be very fair. I'm going to start becoming more and more bold and putting proofs on your tests, okay? And that is definitely a fair proof right there. So you better start learning how to do these things, okay? Alright, let's try another one, okay? If you need to back it up and watch it again, that's what it's there for. Feel free to do that. Alright, number 28. It's kind of the same thought process again, students. I'm going to go ahead and first of all get some numbers in here. I love using numbers on my angles, so I'm going to call this angle 2. I'm going to call this angle 3. I'm going to call this angle 4. Now next, I'm going to say, look, if somehow I can prove that this triangle triangle is obtuse or acute or whatever, that can hopefully show this angle here is obtuse. Actually, if I can show that angle's obtuse, then this definitely has to be acute, because we know, listen to me students, we know angles 1 and 2 are a linear pair, they're on a straight line, which means they have to add up to 180. So if I can show this angle here is greater than 90, like 91, then this has to be 89 or smaller. Let me say that again. If I can show that angle 2 is obtuse, that means it's greater than 90, then this has to be less than 90, because 90 plus 90 is 180. If this is higher than 90, this has to be less than 90, and if this is less than 90, then it is acute. So my goal is to somehow prove that angle 2 is obtuse, and then I can show that angle 1 is acute. Alright, so I already have all my given written on my triangle here, so I'm going to go ahead and grab this and just slide all of this up to get us a little more room. And not sure what happened there. Let's try this again. Alright, here we go. Now, here's how I attacked this, okay? Obviously, first of all, is my given, okay? Then next, I stated that ABC is obtuse. Triangle ABC is obtuse. And how did I know that? Well, right here, guys, because 2 squared plus 3 squared is less than 4 squared, okay? So that is how I knew that. Now, moving on, I can state that angle 2, the measure of angle 2 is greater than 90. In other words, I can state this obtuse. How do I know that? Well, come on, guys. I already stated the triangle's obtuse, so I know I have an obtuse angle. I guess you could say definition of obtuse triangle if you wanted to. But also the reason would be angle 2 is across from the longest side. See, look at your sides of your triangle. 2, 3, and 4. This is the longest side, so the angle across from that has to be the largest angle. If we have an obtuse triangle, which we do, then that's the angle that has to be obtuse or larger than 90. Okay? Now, look what I put next. Now I'm going to do with angles 1 and 2. Angles 1 and 2 are a linear pair. Now, you didn't really have to state that. If you left that out, I would have no problem with that, okay? But I put that in there. And how do I know that? Well, very simply, definition of a linear pair. Okay, so moving on to number 5. The measure of angle 1 plus the measure of angle 1 plus the measure of angle 2 equals 180, okay? And the reason for that would be very simple. Linear pairs are supplementary, okay? Linear pairs, LP, are supplementary. And that's a theorem or corollary or postulate we learned a long time ago. Alright, now I've stated these two angles are supplementary, okay? Now it makes sense. I want to get angle 2 isolated so I can make a substitution here. So I'm now going to state the measure of angle 2 equals 180 minus the measure of angle 1. Of course, that's subtraction. That's the subtraction property. Okay? Now, why would I do that? Well, think about it, guys. What does the measure of angle 2 equal? It equals 180 minus 1. So if that equals 2, could I not pick that up and put it right here for angle 2? Sure, I could. It's called substitution. So I'm going to get rid of this and put this in place of it, so it'll look like this. Are you ready? Here we go. It'll look like this. Remember, this is gone. And I'm going to put this instead in place of angle 2. So 180 minus the measure of angle 1 is greater than 90. Alright? Wow, this is going to be really sweet. This is going to work out really well. And of course, the reason for that would be substitution. Substitution, okay, that's my reason. Now, look what I do next to number 8. I'm going to bring my angle 1 over to this side and make it positive, and bring my 90 over and make it negative. Okay, so I'm left with 90 is greater than the measure of angle 1. Of course, the reasons would be addition and subtraction. I actually did both. I added and subtracted. I brought the 90 over, made it negative, as subtraction. I brought the -1 over and made it positive. That's addition. Okay, that's fine. So, and I'm done. Look, guys, read this. The measure of angle 1 is less than 90. The measure of angle 1, you can say 90 is greater than angle 1, or you can say angle 1 is less than 90. So as soon as I state that angle 1 is less than 90, I can now state that angle 1 is acute by the definition of acute angles. Definition of acute angle. Alright, definition of acute angle. So there it is. It's not the best part in the world. But it's pretty good proof, okay? Alright, let's move on now and take a look at number 29, okay? Now this is not really your standard proof. I'm just going to do some math things here and then show this to you, okay? So watch carefully. Now they want us to show that if A, B, and C are Pythagorean triples, that's my given. So I'm given A squared plus B squared equals C squared. Okay, I'm given I have a Pythagorean triple, so this is true. Then KA, KB, and KC, where K is greater than 0, represent the lengths of the sides of a right triangle. Let's see. I'm going to multiply everything by K. I can do that. That's totally legal. In fact, I'm going to multiply everything by K squared. And you'll see why I'm doing that in a second. I'm going to multiply everything by K squared. I'm totally allowed to do that. That's called the multiplication property of equality. Now, next, I'm going to simplify, okay? Let me show you something over here, students. If I had 2 squared x squared, I could rewrite that, put 2x in parentheses, and put my power of 2 on the outside. That's totally legal, because both of these had a power of 2, so I put it on the outside, okay? So, with that in mind, both of these have a power of 2, so I'm going to put AK squared plus, pull the 2 out, BK squared equals CK squared. And there it is. Look what it says. It says, then if A, B, and C are Pythagorean triple, then prove that KA, KB, and KC represent the lengths of a right triangle. And they do. AK is the same thing as KA. So KA, KB, and KC, look, square squared plus equals this squared. This is totally proving you have a right triangle. This is a pretty weird problem, but it was still good thinking. Some of you will get it, some of you won't, but it's good. It's a good thinking problem for you, okay? Alright, moving on to number 30. Use the results from 29 in the Pythagorean triple, 5, 12, 13, to show which of the following can represent the lengths of the sides of a right triangle. Now let's go back. Can I tell you what they're trying to teach you here? Please, please listen to me. They're trying to show you that if you have a Pythagorean triple like 3, 4, and 5 are a Pythagorean triple, if you multiply each side by k, or in other words the same number, you will continue to have a Pythagorean triple. In other words, I know this is a Pythagorean triple, trust me it is. If I multiply all these by 5, then guess what? I have a Pythagorean triple. You're guaranteed that's a Pythagorean triple. If I multiply all these by 10, you are guaranteed that 30, 40, and 50 is a Pythagorean triple. So you can take a Pythagorean triple and multiply it by anything, as long as you multiply it to everything, and you will get out another Pythagorean triple. And that's what they're trying to show you here by this proof right here. So with that in mind, I know I have a Pythagorean triple of 5, 12, and 13, okay? So with that in mind, and forget these underlined parts, you can see already these are the correct answers, okay? But I'm not going to worry about that right now. Now, let's take a look at the first one. I have a 5 here, and I have a 50. So it looks like I multiplied this by what? 10. Well, if I multiplied all of these by 10, then I definitely have a Pythagorean triple. Let's see if I did. 5 times 10 is 50. 12 times 10 is 120. 13 times 10 is 130. So yes, this is a Pythagorean triple, because I started off with a Pythagorean triple right here. They gave that to me right up here, and I multiplied all the numbers by the same number. Let's take a look at B, okay? I went from 5 to what? 20. So it looks like I multiplied by what? 4. Well, let's see if all these numbers were multiplied by 4. 5 times 4 is 20. 12 times 4 is 48. 13 times 4 is 52. So no, this is not a Pythagorean triple. It is not. Alright, let's take a look at letter C. Alright, I went from 5 to 1 1/4. Now let's talk about that. 1 1/4 is the same thing as what? 5 fourths. I really have 5 fourths. 3 and then 13 fourths, because 3 1/4 is the same thing as 13 fourths. So I had a 5. Now I have a 5 fourths. So it looks like I divided this by 4. Now before you scream out Mr. Earhart, you never mentioned divide, you mentioned multiply. Well guys, division is the same thing as multiplication. Instead of saying divide by 4, we'll just say we multiplied it by what? 1/4. Same thing. Multiplying by 1/4 or dividing by 4 is the exact same thing. And I think it's a little quicker here to divide by 4. So I took this, I went from 5 to 5 fourths, which means I took my 5 and I divided it by what? 4. So let's see if I took each of these numbers and divided by 4. 5 divided by 4 is 5 fourths. 12 divided by 4 is 3. And 13 divided by 4 is 13 fourths. So check. Yes, that is a Pythagorean triple. And now we come to this one here. My 5 was changed to a 1. So I really divided by 5. Or if you don't like that, you can say I multiplied it by 1/5. Same thing. Exact same thing. I'm going to stick with division. So I took 5 divided by 5 and I got 1. So if I take 12 and divide it by 5, do I get 2.4? Let's see. 12 divided by 5. 2, 10, 2, bring down to 0.4. Yes, you get 2.4. Now let's take 13 divided by 5, see if we get 2.6. And trust me, you will. 5 goes into 13 2 times. 2 times 5 is 10. Subtract, put a decimal, bring down a 0, and you get 2.6. So 5 divided by 5 is 1. 12 divided by 5 is 2.4. 13 divided by 5 is 2.6. So yes, this is a Pythagorean triple. So I hope you're seeing what they're teaching you here. Whenever you have a Pythagorean triple, you can multiply all of the numbers by any number, as long as it's the same number times all 3 numbers, and you will come out with another Pythagorean triple. Okay, you were taking a trip. You begin in Cincinnati, Ohio, and you fly 403 miles due east. So here's Cincinnati. We're going to go due east to Washington, D.C. And that distance was 403. Then you fly 546 air miles to Atlanta, Georgia. Now, when I first set this problem up, I tried to work these out ahead of time. I went straight down. Then it dawned on me that it had to be wrong, because it says you flew 546 miles, and then when you flew back to Cincinnati, you flew 369. Do you see the problem with this? If there's a hypotenuse, I'm not saying there is, but if there's a hypotenuse, it would be here. And the hypotenuse has to be the longer side, and this is longer than this. So that's when it dawned on me, okay, 546 is my longest side, so when I draw it, I better make that one be my diagonal side, okay? So there's Atlanta right there, and I flew 546 air miles to Atlanta, and then from Atlanta I flew back to Cincinnati. So I went up to here, and that was 369 miles. Now, here's their question. Is Cincinnati directly north of Atlanta? Well, if it is, think about it. If Cincinnati is directly north of Atlanta, then I have what angle here? A right angle. Because think about it. This is due east right here. It said that right here. Due east. And if Atlanta is due south of Cincinnati, then I must have a right angle here. So the only way to know whether or not I have a right angle here is to see if I have a Pythagorean triple. So you're going to see it's not, it doesn't work. If you take 369 squared plus 403 squared and compare that to 546 squared, I will very quickly see what you'll get here, but it's not going to be equal to each other. 369 squared plus 403 squared, you're going to get 298,570. Okay, and then square 546, and it's going to be close. It's going to be close, but it's not going to be equal. 298,116. Okay, so no. The answer is no. What was it? C below, but the answer is no. It is not directly due south because I do not have a right angle here. All right. Okay, moving on to number 32. Before I start solving number 32, I'm going to go ahead and draw a picture. I should have taken a picture out of the book, and I did not. But we have, I'm not going to try to draw it very well here. I'm just going to, in fact, I'm not going to draw it well at all, but I'm going to draw it big enough so you can letters up here, but it says AB is 5.4. Okay, that would be this length right here. From here to here is 5.4. If you look in your book, you'll see this is A, this is B. Or this is B here, and this is A over here. BC is 152.5. That would be this line from here all the way down to here is 152.5, okay? Then they tell us that ED is 17.6. Now that's this line right here, this slanted line is 17.6, okay? And then it says CE is 5.25. That's that little sliver right there is 5.25. So I'm going to take this right triangle right here. I'm going to draw it off to the side for you, okay? So watch. Here's the right triangle drawn a lot bigger. Okay, that's this right triangle right here, down, over to the right, and back up. That's a right triangle, okay? So, with that in mind, this length here is 17.6. This is my right angle here, and this right here is 5.25, which is this little sliver right here from here to here, okay? Now, let's find this missing side here. If I find, you say, why would you find that mystery heart? Because it says, how tall is the monument? So I want to know the height from here to here. Well, I already know that. Then find this little height here. Then add the two together, and you have the total height. Okay. So this is Pythagorean Theorem. This is old math. So I have leg squared plus leg squared equals hypotenuse squared. Okay. So very quickly, I'm going to square 5.25, and I'm going to get 27.5625. So x squared plus 27.5625 equals, and then 17.6 squared is going to be 309.76. Now subtract 27.5625 from both sides, and you're going to get 282.1975. And then divide both sides, or take the square root. Take the square root of both sides, and you will get 16.79. I'm going to put 16.8. So x equals 16.8. So this sliver right here going up, which is this little sliver right here going up right there, is going to be 7 or 16.8. So students, think about it. I now know the height from here. Let me change the colors. I now know the height from here all the way down to here. It's this right here. And now I know the height from here all the way up to here. It's this right here. So add those two together, and you're going to get the correct answer of 169.29. I'm just going to put 162.3 meters. Okay, and that is the correct answer of they have 169. Oh, it is 169. My fault. My calculator is saying 169. I just copied that wrong, sorry. So 169.3, okay? 169, that looks pretty bad. 169.3 is the answer. Okay, alright, moving on to 33. Alright, now the volume of a pyramid is 1/3 times the height times the base. They want us to find the volume of the pyramid that forms the top of the Washington Monument. Now, I have very, very limited drawing skills. I will do the best that I can to show this to you, okay? Here's the top of, well, actually, it would really help if you look in your book, because I'm not going to be able to draw this very well, but if you look in your book, you'll see the top part of the Washington Monument looks like a pyramid. It would be a square pyramid, something like this. Anyways, yeah, here's the point of the pyramid. Now, I know that you artists in the class are really jealous of my amazingly great drawing skills, but hopefully you get the point here. I'm being sarcastic, but it's a square. It's really important you see this. It is a square pyramid, okay? And I really wish I could draw that a little better. Yeah, that's much better. Yeah, I'm being sarcastic. Anyways, so we have a square base. Don't miss your heart. Why are you trying to show us we have a square base? Because look what we have to do here. And look, students, it tells you right here. Please learn to read and listen. It says the volume of a pyramid. And what are we trying to find? The volume. Find the volume. The volume of a pyramid is 1/3 times the height. We already know the height. We already found that, okay? We know the height of this pyramid is right back here. Remember, it's this line right here, which is how high the pyramid was, 16.8. So I know the height already is 16.8. Times B. B is the area of the base. I have to find the area of the base. Well, students, there's no way you can find the area of the base unless you know what the base is. So I'm trying to show you have a square here. It's called a square pyramid, okay? We'll learn some of these later on this year. There's triangular pyramids, square pyramids, rectangular pyramids. This is a square pyramid. So if I know, now think this carefully, guys. Look at this carefully. Watch. If I know the distance from here to here, going across right here, is 5.25. Okay, 5.25. Then I know going all the way across is going to be 10.5. So all the way across this whole square here is 10.5, and this would also be 10.5. So the area of the base is going to be 10.5 times 10.5, which is 110.25. So the whole area of this base right here is 110.25. So in order to find the volume of this pyramid, I have 1/3 times the height times the area of the base. So I have 1/3 times 16.8 times the area of the base, 110.25. Okay, so I'm going to grab my calculator real quick, and if I don't drop it first of all, and I'm going to take 110.25 times 16.8 and then multiply that by 1/3, and I'm going to get the correct answer if I take this. Really, you can go in any order you want to, students. You can take 1/3 times 16.8, and whatever you get, then multiply it by 110.25. But trust me, if you do all that with a calculator, I got on my screen 617.4, and that's what they have right here, 617.4. There have been some really awesome, good, challenging homework problems during this homework video. I hope this video has been a help to you. If you have any questions at all, please do not hesitate to call or email.